In this nugget, we'll walk through a solution for troubleshooting ticket number 6. So our objective here in ticket number 6 is to get PC2 over here in VLAN 10 to be able to connect to the web server or this internet server out here on the internet at 209.65.200.241. So let's get to it. So the first thing we're going to do is I'm going to bounce the VLAN 10 interface here on DSW1 just to rule it out as a possibility of causing an error in our lab environment. And then after a few seconds, we'll bring it up with a no shutdown. And now let's go on to PC number 2. Here on PC number 2, let's do an IP space DHCP, and let's hope for an IP address from a DHCP server. And right off the bat, let's see if we can build a path all the way to the server on the internet. So we made it all the way up to 10.1.1.9. So if we look at our topology, 10.1.1.9 is this guy. So R3 was as far as it got. And then R3 reported back to us at PC2 saying, hey, destination unreachable. So let's make a road trip to R3 and talk to it. Here on router 3, let's do a show IP route, and I'm going to add a pipe symbol and say begin gateway. So this is still showing us the full routing table. It's just not showing us the decoder information that would go above the line that has the word gateway in it. So as we look at the routing table here on R3, I don't see a couple things. I don't see a 209.anything, and I also do not see a default route, and that's a problem. That's why R3 can't forward it any further to its destination, because it does not have a route in its routing table to do that. R3 should be running OSPF, and it should have a neighbor adjacency with R4 as well as R2 based on our topology. Let's find out if it has those neighbors in place. We'll do a show IP OSPF neighbor, and survey says, yes, we have 2 neighborships. So it's obvious who 4.4.4.4 is. That's the highest IP address on a loopback on R4, which is also the router ID for R4. And 10.1.1.5 is the router ID that's being used by R2. Now, I know a couple of things from our previous experience with these labs, and that is there's a default route being advertised by the ISP router to R1, and R1 has a default information originate statement in its OSPF. We've seen both of those previously as we've gone through other trouble tickets. And for some reason, R3 is not learning about that default route. And there's a few possibilities. Maybe R1 and R2 are not OSPF neighbors, and therefore R2 never would have learned about the default route. Or perhaps the ISP router isn't advertising a default route over to R1 anymore. Those are all possibilities. So let's make a stop at router R2, and we'll look at the routing table there and look for that default route to see if it's present here on R2. So here on router 2, let's do a show IP route. We'll also do the pipe begin gateway to save a little bit of output space on the screen. And on R2, I do not see a default route. And if we wanted to see if R2 is a neighbor with R1, we could do a show IP OSPF neighbor just to verify whether or not a neighborship is in place. So there's R1's router ID and there's R1's address. So our neighborships are solid here on R2. Let's go up to R1 and see what R1 says. So here on router 1, let's do a show IP route pipe begin gateway. So we'll see everything from the line that has the word gateway in it and below in the routing table. And sure enough, R1 does not have a default route. It is not present. So I see right here that we have a BGP routing entry in our routing table. So that right there implies that BGP is working between R1 and the service provider. And I've also got a whole bunch of OSPF routes that I've learned from our good buddy R2. And while we're sitting here at R1, let's take a look at the running config regarding router OSPF. And we can do that with show run pipe section router OSPF. And in a simulation, we could do a show run and just go to that section of the config as well. So here in OSPF, we have default information originate. And what that means is we're only going to be originating a default route in OSPF if, big if here, if we have one. So if R1 has a default route, which based on the routing table it doesn't, it would then generate a default route for OSPF. But since there is no default route, it's not going to source a default route for OSPF. Now, one of the fixes here is we could add on the keyword always, tag that onto the end, and then R1 would generate a default route regardless of whether or not it had its own default route. And in our scenario, default information originate always, you know what, that would work. And the reason for that is if R1 received a packet destined for the web server, because R1 has learned a network, which happens to be the network where our internet server lives, R1 indeed, even without its own default route, would be able to continue to forward in the direction of that internet server. However, for any other destination that we may have on the internet, R1 would not be able to forward it. So probably the best solution here is to fix the problem of why. we aren't getting our own default route on R1. The other option here on R1 could be a static route. This simply says, hey, the default route is pointing to the ISP's IP address as the next hop, and that would also fix this problem. So we have several options here that we could use to implement a solution. So based on this BGP routing entry already present, we know that BGP is working, the neighborship between R1 and the ISP. So let's make a road trip out to the ISP's router, which is called ISP BGP Web. And here, let's take a look at the running config, specifically the router BGP portion of the running config with the show run pipe section router BGP. So right here in the config, we can identify that this router is not using the default-originate option to advertise a default route over to R1. And if we want to verify what routes we are advertising over to R1, we can use the command show IP BGP neighbor 209.65.200.225 space advertise dash routes. And that will show us what we're advertising over to R1. So at the moment, we're just advertising that one network, which happens to be where the internet server is sitting. So for our solution, let's do this. Let's advertise via BGP a default route from the ISP's router over to R1. And we can do that by going into configuration mode, going into router config for BGP 65000.002, and add the statement neighbor 209.65.200.225 space default-originate. And that will advertise a default route from this router over to R1. And one way of verifying that is we can use that command we used earlier, the show IP BGP neighbor 209.65.200.225 space advertise dash route, and it comes up nothing. So I'm going to give BGP just a few moments for it to think about life, consider what it should be advertising to the neighbor R1. Let's use the up arrow key, press enter, and there we go. So you'll notice here under network, it still just shows that one network, but it also indicates right here that we're now originating a default network for the benefit of R1. So if we make a road trip back to R1, here on R1, if we use the up arrow key a couple of times to do a show IP route again, you'll notice that now we have a BGP learned default route with the next hop of .226, which is the BGP router from the service provider. And due to this command, the default information originate in OSPF. Because R1 now has a default route, it is also now advertising or sourcing a default route in OSPF. So if we want to go verify on R3 that R3 has a route, previously it didn't. Now if we do a show IP route here on R3, it should also have a default route, which it does, using 10.1.1.5 as its next hop. And that 10.1.1.5 is R2. So let's go all the way back to PC2 where we started. And let's hit the up arrow key and verify whether or not we can get a trace all the way to the internet server. And survey says success. So there's 209.65.200.226, which is our service provider router. And that service provider router has a loopback with that internet server IP address that we're using as a target. And we could also ping that destination of 209.65.200.241, and that should come back 5 out of 5 as well, which is excellent. In this solution walkthrough for troubleshooting ticket number 6, we identified that the fault domain was this time our ISP router. The technology was IPv4 BGP routing, and the fix was that we needed to advertise or source a default network from the ISP so that R1 could have a default route. I appreciate you joining me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.